All right, welcome to the Explainer. Ever wonder what keeps the planets from just, flying off into deep space? What's the invisible force that makes them do their silent looping dance around the sun? Well, the answer is pretty simple, and it's maybe the most important rule in the whole cosmic playbook: gravity. Today, we're going to break down exactly how it runs the show in our solar system.
Okay, but before we really dive in, let's do a quick gut check. I want you to look at these two statements right here. First, gravity exists only on Earth. And second, planets move at the same speed throughout their orbit. What do you think? Agree? Disagree? Just take a second. Got your answers? Cool. By the end of this, we're going to circle back and see how you did, because getting these right is kind of fundamental to understanding, well, everything.
So to really get a grip on why gravity does what it does, we've got to start with how things are actually moving up there. I mean, what kind of path is a planet like Earth or Mars actually tracing through space? The answer might not be what you think. Okay, so that path is called an orbit. I know, you've heard this word a million times, right? It's just the track that an object, say a planet or even a satellite, follows as it goes around a much bigger object, like our sun. Seems simple enough.
Well, here's where we hit our first big surprise. Most of us, when we picture an orbit, we see a perfect, neat circle. But that's a total myth. The reality is that planetary orbits are actually ellipses. And an ellipse is really just a circle that's been kind of stretched or squashed a little bit. And yeah, of course, scientists have a fancy word for this stretchiness. It's called eccentricity. It's pretty simple, actually. An orbit with an eccentricity of 0, that's your perfect circle. And the higher that number goes, the more stretched out and oblong the orbit gets. And you know what's wild? This stretchiness is all over the place, even just in our own solar system. Just like a Mercury, its eccentricity is pretty high, so its orbit is very obviously an ellipse. But then you have Venus. I mean, look at that number. It's so close to 0, its path is one of the most perfect circles we've ever found. What a contrast. Okay, so that leads to the big question, right? If these orbits aren't just simple circles, then what's the invisible force that's shaping these weird elliptical paths? Well, this is where we finally get to the star of the show. Let's bring this right back down to Earth for a second. Picture it. You're on a trampoline. You bounce as high as you possibly can. But what happens? You always come back down. You don't just keep going up into space. And that force that's pulling you back every single time is, you guessed it, gravity. And this is the key. Gravity isn't just an Earth thing, not at all. It is a fundamental, attractive force that exists between any and all objects that have mass. I mean, think about that. That means you, the device you're watching this on, and the sun, which is millions of miles away, you're all pulling on each other with gravity. Right. Now, so how strong is this pull? It really just boils down to two simple things. First up is mass. The more massive something is, the more gravity it has. That's why we orbit the gigantic sun and not the other way around. Make sense? And second, there's distance. The farther apart things are, the weaker that gravitational pull gets. Okay. So we've got our two main puzzle pieces. We've got these elliptical paths the planets are on, and we've got this universal force called gravity. Now let's put it all together. This is where you see this perfect cosmic balancing act. You can think of an orbit as a kind of cosmic tug of war. Seriously. In one corner, you've got the planet's own momentum, its tendency to just fly straight off into space. But in the other corner, you have the sun's gravity, constantly pulling it inward. An orbit is the beautiful path that gets carved out when those two forces are locked in a perfect, never-ending balance. And this balancing act, it's the exact reason why a planet's speed is always changing. Which, remember that question from the start? So, look here. When the planet gets closest to the star, at point C, gravity's pull is super strong. That pull yanks on the planet, accelerating it, making it whip around the star at its fastest speed. But then, as it swings way out to point A, the farthest point in its orbit, gravity's grip gets weaker, and the planet slows way down before it falls back in and the whole cycle starts over again. Now, this all sounds like a really neat theory, doesn't it? But how do we know it's true? What's the proof? Well, it turns out that understanding gravity has basically let us become cosmic detectives, solving massive mysteries without ever leaving our own planet. Let's wind the clock back to the 1840s. Astronomers are looking at the planet Uranus, charting its path. But something's weird. It's wobbling. The path it's taking through space just doesn't quite add up. It doesn't match what the math said it should be based on the pull from the sun and all the other known planets. So they came up with this incredible hypothesis. They said, what if there's another planet out there? Something we can't see. A kind of ghost planet whose gravity is secretly tugging on Uranus, pulling it just enough to cause that weird wobble in its orbit. So using only the laws of gravity, the very rules we've been talking about, and a whole lot of math, they calculated exactly where this ghost planet ought to be. And then they pointed their telescopes to that precise spot in the night sky. And you know what? There it was. Neptune. They had literally discovered a new planet with math. It was just this stunning, undeniable proof that our understanding of gravity was spot on. Okay, so let's go back to those two statements from the very beginning. How did you do? First up, gravity exists only on Earth. Well, we know that's not true. It is a totally universal force, and its invisible tug on Uranus is what led us to find a whole new planet, Neptune. So, myth, busted. And number two, planets move at the same speed. Also nope. They speed up when they get close to the sun and slow right down when they're far away, all because of that cosmic tug-of-war between momentum and gravity. So yeah, that myth is busted too. And I want to leave you with one last kind of mind-blowing idea to chew on. We think of our sun as this giant, immovable rock at the center of everything, right? But the truth is, the gravitational pull of our tiny little Earth is actually strong enough to make the sun itself wobble just a little bit. It's the perfect reminder that in this huge cosmic dance, absolutely everything is connected and everything is pulling on everything else. It's pretty amazing to think about. Thanks for tuning in.